Okay, next thing we're going to talk about is a unit vector, and in order to find a unit vector is you have to take your vector, take your vector and divide it by the magnitude of that vector, or the distance of that vector. So in other words, you can do this, 1 over the magnitude of your vector times your vector. All right, so let's get started and let's do it. So we are going to do, let's see, V. And so if we take a look at V, if we want to do the magnitude of V, oops, it's the wrong thing, hold on. If we want to do the magnitude of V, we can just go 1 over, and remember magnitude is where we're just finding the distance of this. So the square root of -2 squared plus 5 squared. This whole thing times your actual vector, and our vector is -2, 5. So this is equal to 1 over the square root of 29. We're going to multiply that times -2, -2, 5. So what we end up with is -2 over the square root of 29 and 5 over the square root of 29. Now, of course, they want you to check it to make sure that this works. So in order to check it, we're going to do it over here. We're going to find the magnitude of this right here and make sure it's equal to 1. The magnitude, the distance, right? So our magnitude needs to be equal to 1. So I'm going to say the square root of -2 over the square root of 29 squared plus 5 over the square root of 29 squared, which is going to give you 4 over 29 plus 25 over 29, which of course is the square root of 29 over the square root of 29, or a square root of 29 over 29, which gives you 1. Therefore, you are correct. Okay, go ahead and pause and give it a go yourself, and when you're ready, start up again, and I will give you the answer of the next one. Here's the answer. Okay, let's move to the next one. Okay, first let's go ahead and plot this. So at 2, my initial point is at 2, -5, which is right here. And my terminal point is -1, 3. So my vector looks something like this. Now, to find the linear combination, or write U as a linear combination of the standard unit vectors I and j, if you remember, all we had to do is we had to take our, find the difference between our terminal to our initial point. So we're going to go -1 minus 2, this to this, and then we've got 3 minus -5. So we end up with -3, and this is 8. So therefore, in standard form, this would be -3i plus 8j. And that's it. Okay, go ahead and do your checkpoint. When you're ready, come back and we will see if you got it right. All right, here's the answer. Let's go to the next one. All we're going to do here is a difference and some scalar multiplication. So let's do it. So we're going to do our scalar multiplication first. So 2 of u, which is 2 times -3i plus 8j, minus 3 times your v, which is 2i minus j. So we've got -6i plus 16j minus 6i. This was minus j, so plus 3j. When we add that all together, we got -12i plus 19j. Okay, go ahead and pause, give the other one a go, jump back on when you're ready to see the answer. And here's the answer. Okay, so directional angles. So what you need to think about with direction angles is it is the same thing as a circle. So you see you have x and you have y, which is the same thing as cosine theta, the trig, and sine theta. Okay, so remember how we did that? So remember that your x is your cosine theta and your y is your sine theta. That is what you're doing here, and hence your x is cosine and y is sine, and when you put it into standard form, here you've got. Now, if you think about that, okay, so think about what if we said AI plus BJ, okay? So when we talk about here, all we're doing is we're multiplying by our magnitude, or we're multiplying by the distance to our original vector. So once we get there, now, once you get there, when you're looking for your actual direction, your directional angle of theta, think about this, okay? So theta is when you're going to use your tangent, right? And so tangent is sine theta over cosine theta. So that's why we end up with B over A, because this is your sine and this is your cosine. All right, let's try it out. Okay, so to find the directional angle, now we're talking about the blue, this is our vector right here. And so remember that to find the direction, we're going to do the tangent of theta is equal to B over A, which is 3 over 3. So therefore we have the tangent of theta is equal to 1. Now what you need to think about here is this is sine and this is cosine, or y and x. So the first thing we need to think about is what quadrant is x and y positive in? Well, obviously it's right here. So we are in quadrant 1. Okay, so now when I solve this, I'm going to go theta equals the tangent inverse of 1, and that means theta is equal to 45 degrees. That means this right here is 45 degrees. Okay, let's go on to the next one. So one of the most important things you need to think about is where are you at? What quadrant are you in? So here we've got 3 and -4. So we want to go to 3 and -4, which tells you that we are in the fourth quadrant. So my A is 3, my B is -4. So now I'm going to do the tangent of theta is equal to -4 over 3. So therefore theta equals the tangent inverse of -4 over 3. When you do that, you end up with theta equals -0.9273. These are rads. So what you want to do is go ahead and multiply that by 180 over pi so that we can put it in degrees, which is going to give you -53.13. So we're talking about that angle of 53.13. So that means that's this angle right here. So now what we need to do is figure out what is that angle. So we're going to go 360 minus 53.13. So your angle is 306.87 degrees. And there's your answer. Okay, go ahead and try the other two. Pause and jump back on when you're ready to find out what the answer is. All right, here's the answer. Okay, so it says find the component form of the vector. So with component form, remember that we just talked about this, where you do the magnitude times the cosine of theta plus I plus the magnitude of sine theta j. Okay, this right here is your magnitude, the 150. And then here is our angle, which is 200. So we just have to go 150 times the cosine of 200i plus 150, because it's distance, right? That's our magnitude. Actually, I shouldn't have this on here because this is our magnitude. Our magnitude is always positive. So let's go back and fix that real quick. So this should just be 150 times cosine 200i and 150 times sine 200i. When you do that and pop it in your calculator, you get -140.95i plus -51.3j. So therefore our component form would be -140 140.95 and negative 51.3. Now, in order to check yourself, what you can do is this. You want to find the magnitude. Your magnitude should equal 150. So remember, with magnitude, you just do the square root of negative 140.95 squared plus negative 51.3 squared. And that should equal 150, and it actually is approximately 149.99. Therefore, we know that we have the right component form vector. All right, go ahead and pause and give it a go and see if you can get the correct component form on the checkpoint. Jump back on when you're ready for the answer. And the answer is negative 95.6 and negative 25.9. If you put that underneath the square root, you will end up with close enough to 100 miles per hour. Okay, next one. All right, here we go. We're going to get into some physics here. So the first thing you need to see is that your BA, which is right here, BA is the gravity, right? The force of gravity on the boat. And then if you look at BC, BC is right here, and this is the force on the ramp. And then the final thing you have is AC, which is this little piece right here. What that is the force up the ramp. Okay, so they just turned this little triangle right here. They just turned it down so that you can see. So this right here, so if we go back and take a look at the original one, we can look and see that this right here, this little piece right here, is the force up the ramp, right? And then if you look at your BC, BC is the force on the ramp. So this is your BC. And then if you look at BA, that's your gravity, but it just shows better on the other way. Okay, so now what we're going to do is we're going to go through and we're going to find what we're looking for. And what we're really looking for is we're looking for that BW. We're looking for this part right here. So we're just using our trig functions. So the sine of 15 degrees is going to be equal to the opposite, and the opposite was your AC over your hypotenuse, and your hypotenuse is the BW right there, right? Okay, so we already know that a force of 600 pounds is required to pull the boat up, which means that our AC, this is the force to go up. So the sine of 15 degrees is equal to 600 over BW. Now, when we cross multiply and all that, we get BW is equal to 600 over the sine of 15 degrees. When you plug that in your calculator, you end up with approximately 2,315 pounds weight, of how much weight you have. Okay, when you're ready, go ahead and pause, jump back on when you're ready, and we will go ahead and see what the answer is for the next one. And the answer here is approximately 2,404.9 pounds. Okay, let me explain this one real quick. An airplane travels at a speed of 500 miles per hour with a bearing of 330 degrees at a fixed altitude with a negligible wind velocity. And so here, right here, this is going to be our picture. So here's what I want to explain first. So the 330 degrees. So what you need to think about with 330 degrees is, remember when we do bearing, bearing starts north. And it goes clockwise. So this way right here is north. And it went clockwise 330 degrees. What we need to figure out is what exactly degrees is that going back to trig. Now with trig, we don't go clockwise, we go counterclockwise, and we start at the x-axis. So if we ended here at 330, that means this right here is 120 degrees. That's what's left. So we're actually using 120 degrees. Okay, Now, the next thing is then it says, note that the bearing of 300 corresponds to 120. That's where I'm talking about. The airplane encounters a wind with a velocity of 70 miles per hour in the direction northeast 45. Northeast 45 is this green right here. So if we're going from our north, right? We're going north, and we're going 45 degrees clockwise. That gives you this. Now, for us to figure out where is this angle going trig, so going from our x, that's why it's still 45 degrees. Okay, so let's go ahead and solve this. So our first one is, remember, we're going to multiply by our magnitude, and again, our magnitude is 500, and we've got the cosine of 120 degrees, and we've got the sine of 120 degrees. So when we go through and we multiply that, that means our first one is going to be negative 250 and 433. Okay, now to do the wind one. So our next one is going to be 70, because it's 70 miles per hour, times the cosine of 45 and the sine of 45. And when we multiply that out, we get 49.5 and 49.5. Okay, so now what you want to do is you want to do the total velocity. So the total velocity is you're going to add those two together. You're going to add v1 and v2. And so your total velocity is going to be negative 200.5 and 482.5. Okay, so now to find the speed, what the speed is when you do your magnitude. So we're going to go back to here, and we're going to do the magnitude of this right here. So the square root of negative 200.5 squared plus 482.5 squared. So therefore our magnitude is going to be 522.5 miles per hour. There's our first answer. The next thing it asks us is it wants to know the direction of the airplane. So remember with direction, what we had to do is we had to do the tangent. So the tangent theta of, and then we go back here to our vector, and we want to do the sine, which is 482.5, over the cosine, which is negative 200.5. All right, now stop for a second. Think about what quadrant that's in. So our y is positive and our x is negative. So this is in quadrant 2. That's going to tell you how you can find your angle. When you go through and do theta, you end up with theta is negative 1.18. Now that's in rads, so we want to multiply that by 180. Oops. 180 over pi to get it into degrees. So when you do that and you get it into degree, you get 67.4 degrees. But remember, that's 67.4 degrees in the second quadrant. So go to your second quadrant, 67.4, right? So what we want to find out is what degrees is this? So if you subtract that from 180, so 180 minus 67.4, you get 112.6 degrees. That's for us. We want to know the true direction of the airplane. So if we want to know the true direction of the airplane, what we need to figure out, so let me go back and I'm going to erase this real quick and just hang with me here. So we need to figure out right here, this right here is 112.6, right? We want to know how far did we go from here to there, because remember with bearing you start at the north and you go clockwise. So if I figure out how much this little distance is right here, I can just subtract that from 360. So obviously if this is 112, can't I just say 112 minus 90? So if I do 112.6 minus 90, let's see, hold on. I get that this little piece right here is 22.6. So now just go 360 minus 22.6 degrees, and that is going to give you your direction of the airplane. So your direction of your airplane is 337.4 degrees. All right, so you need to give this a go on the checkpoint, see if you can get it right, and I'm going to go ahead and put what the speed is, and I will put what your direction is, so go ahead and pause. Okay, the speed is 451.7 miles per hour, and your direction is 305.1 degrees. Okay, we're done. All we have to do is our vocab real quick. So this one is directed line segment. Directed line segment. This next part here, this is your initial. And then this is your terminal. And then on number 3, the answer is vector. Number 4, the answer is magnitude. And the same direction. That's how if you know if they're equal, they have the same length and the same slope. And then this is your standard position. Okay, standard position. Okay, number 6, the answer is the unit vector. Remember, it's 1 unit. Number 7, the answer is multiplication and addition, so scalar multiplication. And this is addition. And number 8 is your linear combination. And horizontal and vertical. Okay, you're done.